Dear viewers, today we are going to talk about the morphology and distribution of echinoderms. The echinoderms are all marine and comprise the starfishes, brittle stars, sea urchins, sea lilies, sea cucumbers, and the extinct blastoids and the cystodians. The body is often radially symmetrical, the symmetry being generally pentamerous, but in many cases there is also a more or less well-marked bilateral arrangement of parts. In the majority of the cases, the alimentary canal terminates in the anus. A body cavity or coelom is present and surrounds the alimentary canal. The water vascular system is one of the distinguishing features of the group. It consists of a set of vessels containing a watery fluid and generally placed in the communication with the seawater by means of a canal. One vessel forms a ring around the esophagus from which radiating trunks are given off. The water vascular system functions in respiration and as a sensory organ, and often also in locomotion. A nervous system is present. One part of it has a distribution similar to that of the water vascular system. Reproduction is mainly sexual. As a rule, the sexes are separate but do not differ externally. In nearly all the echinoderms, there is a dermal skeleton. This is calcareous and consists of sometimes of isolated pieces, but more usually of rods or plates, united by fibers of connective tissue and forming a complete shell or test, which may be either flexible or rigid spines, and other processes are often attached to the plates. When examined microscopically, each part of the skeleton is found to be formed network of calcareous rods with jelly-like substances in the spaces of the network. The details of the structure different forms, of course, depending on the size and shape of the spaces between the rods. In the spines of the sea urchins, the network of rods has usually a radial arrangement with a polygonal or rectangular spaces except at the center, where the structure is more irregular. Another characteristic feature of the skeleton is that each component part shows the optical characters of a crystal of calcite and differs only from an ordinary crystal in not having the crystal contours and in the possession of the netted structure. In a plate, the principal crystallographic axis is at right angle to the surface. In a spine, it is parallel with the length. In fossil specimens, the spaces in the network of rods usually becomes filled with calcite, which is deposited in a crystalline continuity with that forming the plate or spine. In such cases, the characteristic cleavage of the calcite becomes well marked, so that when the plate or the spine is broken, the fracture passes along the cleavage planes instead of being irregular as in the recent forms. By the infiltration of calcite and the development of cleavage, the organic structure in fossil echinoderms is sometimes partially or almost completely destroyed. The Cochinoderma are divided into two main groups, that is Elithozoa and Pelmatozoa. The Elithozoa possesses no fixing organs and are able to move about freely. This group is divided into three classes: number 1 Asterozoa, number 2 Echinoidea, and number 3 Holothuroidea. Coming to the first class, that is the Asterozoa. The Asterozoa are represented in the order Paleozoic rocks by a great diversity of forms, but these in the main can be arranged into two groups which have survived to the present day: the Asteroidea or starfish and the Ophiuroidea or the brittle stars. The Asteroidea are the simple of these two groups and have undergone less modification from the present Asterozoan stock. All the forms of Asterozoa are built around the water vascular system in a more or less similar way. There is a central mouth inside the water vascular ring and a disc of varying extent around the mouth. 5 arms, occasionally secondarily multipled, come off from the disc. The main variations in the structure of the skeleton appear to be connected with the manner of the life of the forms and can be best illustrated by an account of the structure of two groups. In the Asteroidea, the arms are usually short and merge gradually into the disc. Occasionally, as in the recent genus Pentagonaster and in the chalk genus Metopastor, the arms are so short that the whole body is almost a pentagon. Other genera, such as the Asteropecten, have longer arms, but no Asteroidea except a few deep sea forms have the long thin arms, which usually characterizes the Ophiuroidea. The two surfaces of the asteroid are readily distinguishable. The undersurface, known as the oral, ambulacral or actinal, is marked by the mouth and 5 deep ambulacral grooves along the arms. In each of these grooves, one of the 5 radial water vessels is placed, and from it arise tubular offshoots known as the tube feet. The upper surface, known as the apical aboral or antiambulacral or abactinal, is completely covered. A distinct ossicle on this surface is the madreporite, the porous place through which the water is admitted into the water vascular system. The ambulacral grooves extend from the mouth to the extreme tip of the arms. Each groove is formed by the 2 rows of ossicles, the ambulacral ossicles, which meet at an angle, making an arc, and is bordered on each side by another row of ossicles. The adambulacrals between the ambulacrals are pores for the passage of the ampullae or reservoirs attached to the tube feet. The tube feet themselves are used for pulling open lamellibranchs, or which starfish feed, and for climbing and walking. The ambulacral groove can be closed for the protection of the tube feet by muscle placed ventrally to the radial water vessels, or opened by muscles dorsal to the same structure. Longitudinal muscles occur between the adambulacrals and at the dorsal tips of the ambulacral ossicles, by means of which each side of the arm can be contracted. The ossicles nearest the mouth in the series with the adambulacrals are called mouth angle plates. They are often so stout that they give the mouth a star-shaped form. In the interradial angle supported the mouth angle plates is a stout plate, or the odontophore. This is not usually visible on the oral surface in recent forms, as it is covered by the ventrolateral plates, but in many Paleozoic genera which do not possess ventrolaterals, it is seen distinctly. In the remaining parts of the skeleton, which are known collectively as the interambulacral skeleton, the following parts are usually clearly differentiated. Number 1. A double series of plates, the supero and the infero marginals, which form the sides of the arm and disc. Number 2. Small plates, the ventrolateral, placed on the oral surface of the disc between the marginal plates and the adambulacral ossicles. And number 3. A central primary circlet of the radial and interradial plates on the aboral surface, usually more distinct in the young than in the adult form. Number 4. Plates which fill in the remaining portions of the aboral surface. The plates running down the middle of the aboral surface of the arm are known as the radials. The terminal member of this series is notched for the reception of the most distal tube foot, which possesses an eye spot, and the plate is therefore known as the ocular. Some or all of the plates of the interambulacral skeleton may be partly cut away to allow the tube-like projections of the skin, which form the simple respiratory organ known as the double bronchial or papillae. All the plates except the ambulacrals may carry spines. The disposition of the spines is of the importance in classification. In the genera found in the chalk, the ornamented formed by the pits in which the spines are sunk may be used to distinguish genera and even species. Frequently, some of the spines are modified into the pincer-like organs, the pedicellariaceae, which serve for the protection and as a mean of the clearing of the surface of the body. The soft parts follow the general radiate or radial symmetry already noticed in the water-vascular system. The mouth leads into the short esophagus, which opens into a globular stomach. Above this stomach is the pentagonal pyloric sac, from which the angles of which are given off branches, which soon divide into two and extend down the arms near the aboral surface. From the pyloric sac, a short narrow intestine leads into the anus at the center of the aboral surface. The distribution of the main parts of the nervous system is similar to that of the water-vascular system. It consists of a ring around the mouth and of a branch which extends down the ambulacral groove of each arm. There is also a layer of fine nerve fibers under the ectoderm. The genital glands occur in the pairs at the base of each arm and open to the exterior between the rays. The water-vascular system communicates with the exterior by means of a canal which passes from the circular vessel to the madreporite on the aboral surface of the disc. This is known as the stone canaft, on account of the deposit of the carbonate of lime in its walls. And a subclass second, that is the Ophiuroidea. The Ophiuroidea are a highly modified group. The arrangement of the nervous and the water-vascular systems is similar to that found in the Asteroidea, but the 2 feet no longer have any locomotory function, being merely sensory or respiratory organs. The arms are long and thin and are capable of wriggling and writhing movements. The disc is round and sharply marked off from the arms. Many ophiurids live on the mud from the sea bottom, which they push into their mouths by means of the 2 feet nearest to the mouth. The ambulacral ossicles are no longer pairs of rod-like bodies, but consists of a single series of stout vertebrae which articulates upon each other. The derivation of these vertebrae from pairs of ambulacral ossicles can be followed in the young forms and in the older Paleozoic fossils. The adambulacrals are represented in the thin section or by thin section of the arms of the plates, known as the lateral plates or side shields, which usually possesses a ridge carrying a comb of long spines. The aboral surface is protected by a series of dorsal plates analogous to the radials of the Asteroidea. The groove is covered by ventral plates not represented in the Asteroidea. Neither generative organs nor diverticula from the alimentary canal enter the arms as they do in the Asteroidea. The oral surface of the disc is formed by interradial pouches covered with scaly plates or scaly plates and granules. The slits between the pouches and the arms serve as the genital openings and for the entrance of water for respiratory purposes. In the interradial angles between the mouth plates are 5 large buccal plates, one of which serves as a madreporite. The aboral surface of the disc is in the most cases covered with numerous small plates, but usually there is at the base of the arms on each side a large plate, the radial. Some forms have a primary circlet of plates similar to that mentioned for the Asteroidea. The mouth angle plates are fused with the proximal pair of ambulacrals to form stout jaws. A single stout plate, the torus, is situated at the mouth extremity of each pair of jaws. carries a strong spine or teeth which are used for grinding. The Paleozoic Ephyroidea differs from recent forms in several respects. All the best known forms are devoid of ventral plates covering the groove. The radial vessels or radial water vessels are protected by outgrowths of the ambulacral ossicles which form a closed canal. The opposite members of each pair of ambulacral ossicles are not fused into single vertebrae. There are no buccal plates and the madreporite is a separate plate. The vertebrae of some genera possesses articulating knobs and the prominences similar to those in the recent forms. The principal Paleozoic genera are Lapworthura, Eoxinosoma and Protaster. And class 2, that is Echinoidea. The echinoids or sea urchins have usually a globular heart-shaped or discoidal body covered with spines. The shell or the test is covered by a layer of ectoderm and consists of numerous calcareous plates which in majority of the cases are immovably united. Nothing corresponding to the ambulacral groove of the starfish is to be seen on the surface, since the water-vascular system is internal to the skeleton, and as a result the 2 feet in order to reach the exterior must pierce the plates of the test. The mouth is on the inferior surface and is either central or in front of the center. The anus is either at the summit of the test or posterior to it, somewhere along the line drawn from the summit to the center of the base. In regular echinoids, both anus and mouth are central, being placed at opposite poles of the test. In irregular echinoids, this portion is always and the mouth often is eccentric. In the test, we may distinguish 3 parts: a small patch of plates placed at the summit known as the apical disc or apical system, the main part of the test termed and the corona, and the part between the mouth and the lower margin of the corona, which usually bear plates and is known as the peristome. In a typical echinoid of the regular group, for example Echinus, the anus is placed within the apical disc, which then consists of following parts. Near the center is it's placed, which is surrounded by a membrane bearing small plates known as the periproct. The periproct is encircled by a ring form of 10 plates. 5 are called genital and 5 ocular. The genital plates form the inner part of the ring. They are often more or less hexagonal in outline and are usually provided with a perforation which serves as the opening for a genital duct, whence their name. One, the anterior right and is pierced by the numerous pores and is the madreporic plates. Outside the genital plates and alternating with them are the ocular plates. These are smaller than the genital and usually triangular or pentagonal, and each has a perforation through which the terminal tentacle of the radial water vessel projects. This is pigmented and has sometimes been regarded as a rudimentary visual organ. In most of the regular echinoids, the apical disc is large, but particularly so in Cedaris, Selena and Pelastis and their allies. The genital plates are completely separated from one another by the oculars, so that a single row of T plates encircle the periproct. In others, some only of the genital plates are separated by oculars. When the oculars separate the genitals and touch the periproct, they are said to be insert. When they do not touch the periproct, they are said to be exert. Each genital plate has usually 1 perforation only, but in many Paleozoic forms there are 3 or more. In Cedaris, often 2. Similarly, the oculars in a few Paleozoic echinoids have 2 perforations instead of 1. In Selenia and peltastis, there is an extra plate in the apical disc. It is in front of the periproct and is known as the serenal plate. In the irregular echinoids, the apical disc is small since it does not enclose the periproct. The madreporic plates may extend to the center of the disc, and sometimes, for example, spatagnus reach to the posterior border, separating the posterior oculars. The posterior genital is sometimes absent, and when present may be without perforation. In Echinocoris and Holaster, the apical disc is elongated and the anterior genitals are separated from the other genitals by two oculars which join in the middle, and the posterior genital is absent. In Choleritis, the apical disc is still more elongated. Since the two posterior oculars are separated from the rest of the apical disc by a chain of small plates, in Clypeaster, the genital plates are fused together. The corona in typical echinoid consists of 20 columns of plates, each column extending from the apical disc to the peristome. The plates are of two kinds, ambulacral and interambulacral. There are 5 double columns of the ambulacral placed or separated by 5 double columns of the interambulacrals. Each double column is termed as an area. The former and against the ocular plates are latter against the genital, and in each case fresh plates are developed next the apical disc. In each area the plates alternate on either side, and since their inner ends are angular, the line between the two rows is zigzag. The ambulacral plates are smaller and more numerous than the interambulacral, and they are perforated by pores for the passage of the tube feed to the exterior. A radial water vessel being placed in the middle line under each ambulacral area. The pores are usually round but sometimes elongated. In most cases, they are situated in the outer portion of the plates and are generally in pairs. Each pair of pores correspond to a single tube foot. Since each tube foot divides at its base into two canals, frequently each pair of pores is surrounded by an oval raised rim, the peripodium. The two pores in each pair are sometimes horizontal but usually inclined so that the inner pore is lower than the outer one. In some echinoids such as Sedaris and all the Paleozoic genera, each ambulacral plate is formed of one piece. Only such plates are called as simple or primary. In other cases, some of the ambulacral plates are compound, consisting of 2, 3 or more small plates which have become fused together. But the original plates are still indicated by the lines of suture between them and also by a pair of pores on each. In some genera, the plates which are united are all primaries, that is to say, each extends from the margin to the middle line of the ambulacral area. Frequently, some of the plates taper away and do not reach the middle line or inner edge of the compound plate. Such are called demiplates. Others, termed occluded plates, start from the inner margin of the compound plate but taper away before reaching the outer margins. Some, known as included plates, do not reach either the inner or outer margin. This fusion of plates appears to be due to growth pressure, since each plate of the test is enlarging and new plates are being added next the apical disc. Also, the perignathic girdle interferes with the passage of the ambulacral plates onto the peristome. The fact that some of the fused primary plates are smaller than others, and also the presence of demi-plates, is attributed to the reduction in size of the original plates by the absorption of the material under pressure. The pores in the ambulacra of some echinoids are placed one immediately above the other, so that one vertical row of pore pairs is seen. Such pores are termed as the unigeminal or uniserial. In other cases, the pore pairs are alternately near to and more distant from the margin of the ambulacral plate, and consequently 2 vertical rows are formed, and the pores are said to be bigeminal or biserial. In a similar way, 3 or more vertical rows of pore pairs may be produced. When the pores are known as trigeminal or polygeminal, sometimes the pores in each pair are united by a groove on the surface of the plate and are then termed as the conjugate. Whereas in Sedaris, the distance between the 2 rows of pores increases uniformly and slowly, passing from the apical disc to the equator, and the pores are as well developed on the under as on the upper surface of the test. The ambulacra are said to be simple. The plates of both ambulacral and the interambulacral areas are often provided with rounded elevations known as the tubercles and granule. The tubercles are of the various sizes, and the largest being the primary, and those of the smaller sizes are secondarily. In the primary tubercle, the following parts may be distinguished. At the summit, a hemispheroidal piece, sometimes perforated at the top and known as the mamelon. The mamelon rests on the boss, the upper margin of which is sometimes smooth, sometimes crenulated. The base of the boss is frequently surrounded by the smooth excavated space, the areola or the scrobicule, to which the muscles from the spine are attached. The granules are smaller than the tubercles and have no distinct mamelon. Attached to the tubercles are the spines or radioles. These are of different sizes and shapes in different genera and species, and even on the same individual, being needle-like, rod-like, flask-shaped, etc. The larger spines are attached to the primary tubercles, the smaller to the secondary tubercles. They serve for projection and also assist in locomotion. At the end of the spine, where it articulates with the mamelon, there is a rounded cavity, the acetabulum. The next comes the head, limited above by a ring or collar, which may be smooth or crenulated, and serves for the attachment of the muscles that move the spine. Beyond the collar and forming the greater part of the spine is the shaft or stem, which may be smooth or ornamented with ridges or rows of spiny processes. The microscopic structure of the spines varies in different genera and is of importance in classification. Pedicelaria, which consist of a stalk with usually 3 blades, also occur but are rarely found as fossil on the surface of some irregular sea urchins belonging to the suborder Spatangina. There are bands which appear to be nearly smooth but are covered with very minute tubercles in the living state. They bear slender spines, and their cilia produce a current of water which helps to keep the test clean. These bands are termed as fascioles, and their position varies in different genera. Sometimes they form a ring beneath the anus, for example in Micraster, when they are said to be subanal. In other cases, they encircle the rosette formed by petaloid ambulacra, for example in Hemiaster, and are said to be peripetalous, or they extend around the margin of the test, for example in Cardiaster. On the lower surface of the test is the peristome, in the center of which is placed the mouth. The peristome membrane, which extends from the mouth to the edge of the corona, is sometimes, for example in Sedaris, completely covered with rows of thin overlapping plates, but more usually bears 5 pairs of plates around the mouth and only small isolated plates on the remainder of the peristome, or is without the plates. The peristome is usually larger in the regular than in the irregular echinoids. The echinoidea may be divided into 2 orders, number 1 regularia and number 2 irregularia. Order number 1, that is regularia, the peristome is at the center of the base and the anus within the apical disc. The ambulacra are simple Lantern present in all. The test is circular in outline and the radial symmetry is almost perfect. Number 1, endobranchiata includes the Paleoechinus, Macoya, Archaeocedaris, Melonechinus and Cedaris. Number 2, ectobranchiata, margin of the peristome with notches, external gills present, generally some or all of the ambulacral plates compound, but sometimes arranged in groups of 2 or 3 differing in shape and not fused together. They range in age from the Triassic to the present day and contain the Peltastis, Selenia, Acroselenia, Hemicedaris, Pseudodiadema and the Echinus. Coming to the order 2, that is Irregularia, the anus is outside the apical disc and in the middle line of the posterior interambulacral area. The mouth is either central or in front of the center. The test is bilaterally symmetrical, ambulacra simple or petaloid. Lantern and perignathic girdle may be present or absent. Next is the suborder 1, Holactipina. Here the peristome is central with notches. Lantern and perignathic girdle present, ambulacra not petaloid, plates mainly simple but some may be compound. Lias to recent is the age group, mainly Mesozoic. Some of the other genera are Gonulus, Holactipus, etc. The second suborder is Clipiasterina, peristome central without notches. Lantern and perignathic girdle is present, ambulacra petaloid, plates simple, ocular and genital plates fused together. Upper Cretaceous to present day is the age range. It includes Clipiaster scutella. The third suborder is nonina, peristome eccentric without notches, lantern and perignathic girdle absent, ambulacra commonly petaloid or subpetaloid, the plates simple, anterior, ambulacral often different from others. The bilateral symmetry of the test is particularly well marked. Lias to present day is the age range. The genera includes the Nucleolitis, Clepias, Echinolampus, Echinocoris, Micraster, Hemiaster and Cysaster, etc. Distribution of echinoderms. Some echinoids live at greater depths in the ocean. No less than a dozen species having been found below 2000 fathoms and line, and one even 2900 fathoms even. By far the larger number occur near the coast in shallow water. Thus, of the 297 existing species recorded by Agassiz, 201 are found in water often less than 150 fathoms in depth. Echinoids are most abundant where the sea bottom is rocky, sandy or calcareous, and less common where it is muddy. Consequently, fossil forms are rare in clayey strata. Those found in deep water have a much wider range in space than those found in the shallow water. Many genera, especially those with considerable range in depth, have also a long range in time, some extending back to the Cretaceous or even to the Jurassic period. For example, Hemipedina, Calopygus, Phthalenia, Hemiaster, etc. All the Paleozoic echinoids belong to the endobranchiate division of the regular group, with two exceptions. The corona is characterized by consisting of more than 20 columns of plates in each ambulacral area. The number ranges from 2 to 20. Each plate has a pair of pores, so that in some cases the number of tube feet in each area was very large. In the interambulacral area, the number of columns varies from 3 to 14. Some forms have a rigid test, but in many genera the plates of both areas developed so that the test was flexible. The ocular plates are generally insert, and in genital plates commonly have 3 or more perforations. In the Triassic, cedarids are chief forms. In the Jurassic rocks, the echinoids are much more numerous relatively to the other groups of animals. In Cretaceous, the echinoids are even more abundant than in the Jurassic. the Clypeasterina make their first appearance in the Upper Chalk. The commonest forms in the Eocene of the England are Hemiaster and Schizastor in the Eocene of the south of Europe, North Africa and India, etc. Thank you very much.